The last topic that we're going to talk about in this first section on series is the divergence test. The divergence test is a test which is very easy to apply that tells you that certain series diverge. The idea behind the divergence test stems from this remark. In order for a series to converge, its terms must go to zero. If they didn't go to zero, we'd just keep adding big things in our sum forever, and there'd be no hope that we'd settle at a single value. So, let's state the divergence test precisely. The divergence test says that if a series sum from n equals 1 to infinity of an converges, then the limit of the an's must be 0. Now, we need to be a little careful here. The converse of this statement is not true. In other words, there are series where the terms do go to 0, but the series diverges. We saw an example a while ago, the harmonic series, which is the sum from n equals 1 to infinity of 1 over n. So, how is the divergence test applied in practice? Let's demonstrate with an example. Suppose I gave you the sum from n equals 1 to infinity of n squared plus 1 over 2n squared. To apply the divergence test, we take the limit of the terms of the series, and in this case we get a half. So, since the limit of the terms does not equal 0, we find that the series diverges by the divergence test. An important point to note here is that just because the sequence of the terms converges does not mean that the series also converges. The sequence must converge to 0. Let's try a couple more examples. First, let's take a look at the sum from n equals 1 to infinity of minus 1 to the n times n squared plus 1 over 2n. Applying the divergence test, we compute the limit of the terms of the series. Now, the non-oscillating part, which is the part without the minus 1 to the n, goes off to infinity, since the degree on top is bigger. Therefore, this sequence sort of oscillates between going off to infinity and negative infinity. And therefore, the limit does not exist. In particular, it's not equal to 0, and so our original series diverges by the divergence test. As a final example, consider the sum from n equals 1 to infinity of n squared plus 1 over 2n cubed. We'll apply the divergence test, taking the limit of the terms, and since the degree at the bottom is bigger, we get that the limit is equal to 0. So, the divergence test says that the series converges, right? Wrong. All it means is that the divergence test is inconclusive, and we'll have to find another way to tell whether the series converges or diverges. It turns out that the series actually diverges, and we'll learn about some other tests that will be able to detect this later. But for the time being, I'll leave you with this takeaway. The divergence test cannot tell you that a series converges. Just like the name implies, the only conclusion that you can get from the divergence test is that a series diverges. All right, that's all I have for you this time. Thanks everyone, and have a great rest of your day.